be this one is question 5. The first three terms of an arithmetic sequence are as follows, where P is an element of real numbers. Okay. T equals 2P plus 1. T2, T1 equals 2P plus 1. T2 equals 5P minus 3. And T3 equals 6P plus 7. And they said find the value of P. Wow. Okay. This should lead to simultaneous equation. Okay. Let's see. Find the value of P. Okay. So I think the secret to this solving this particular question is for us to understand that if it's an arithmetic sequence, then it should follow the typical behavior of an arithmetic sequence. And that is that T2 minus T1, which is the common difference, should be equal to T3 minus T2. Okay. So that's the basis on which we will solve this question. So let me just see. That's number 5. All right. Okay. So let me just type it here. That the common difference should be between the common difference which is equal to T2 minus T1. Uh, T2 minus T1 and the same B should be equal to T3 minus T2. T3 minus T2. Okay, so let's take on each one now. Starting with T2 minus T1. We take it one at a time and see what we come up with. Okay. So T2 minus T1, if we take based on what the question tells us, it says that yeah, T2 is 5P minus 3. That'll be 5P 5P minus oops 5P minus 3 divided by 5P minus 3. Okay. Minus. Now I have to put a bracket because things may want to get messy with a minus here. T2 minus T1. T1 is 2P plus 1. 2P, oops, 2P plus 1. Alright, so you know what will happen in this scenario, right? The minus will um, uh, affect, we take on each of the numbers in the parentheses, the bracket. So what do you think we'll have in this case?
We open the bracket 5P minus 2P.
Minus 3. Okay, you want to take on it immediately. Okay,
Yes, sir.
let's open the bracket first so that we don't mix up anything. Minus one. Okay. All right. So we're collecting like terms now, right?
Yes, sir.
P minus 2p, which is 3p, and then we're left with minus 3 minus 1. And minus 3 minus 1 is minus 4. Okay. So this is the first bit. Uh, 42 minus 31. Then let's do C3 minus C2. C3 minus C2. After everything, we'll now come and equate the what we might call equation 1, and then the second one will be equation 2. This is supposed to be like a dotted line. That's how I remember all the rules. Okay, yeah. Alright. So C3 minus C2, according to the question, will give us 6p plus 7, 6p plus 7, okay, minus, open another bracket, C2. Okay, and our C2 was 5p minus 3. You remember, if we
Yes,
look
sir.
at it, we can look at above here. Okay, so we open the bracket, and what do we have? We'll have
B.
6p. Okay, maybe we can just click on it directly. Minus 5p. Okay, and then we have plus 7. Um, plus 7 plus 3, right?
Yes, sir.
Because of the math. Okay. All right. So what do we have now? 6p minus 5p is just 2.
P plus 10.
Yeah, 2 plus 10. Thank you. 2 plus 10. All right. So this will form our equation 2. Because Roman numerals I will use. Let me stick to it. So to show some consistency. Okay. Yeah. Okay. All right. So we now go to run things as we expected. So both of them are the common difference. If it's the same arithmetic progression, then they should be exact. This implies, therefore, we just say that this implies that equation 1 should be equal to equation 2. It should be exactly the same based on the principle of equality. Okay, so well, that means therefore equation 1 is 3p minus 4, so it will be equal to what? P plus 10, right?
Yes, sir.
So you know what happens next? We just collect like terms. Where do you think P should move to? P should
3
P
to
should
P.
move to, yeah,
Okay. To P.
yeah,
Yes.
yeah, and then this guy comes to this side, right?
Okay, sir.
Yeah. So this will be 3p minus p equals 10 plus 4. 10 plus 4. And 10 plus 4, we know is 14. So let's just put our 14 there. And then 3p minus p is 2p, which means p will be nothing but 7 by the time we divide both sides by 2. Okay, so we don't do that division sign well. So it's not looking like something else. Okay, let's see. Alright, so first question is knocked off the first question. Therefore, P is 7. Yeah, okay, so that's the answer to the first one. Let me zoom out so that we can. Oops, I don't want too much. Okay, can you see it?
Yes,
You want
sir.
to do it? Screenshot.
I've screenshotted.
Okay, cool. Okay, so let's go to number 6. I expect it should be number 6. That should be the next one. Okay. Oh, 5B. So, not number 6. Okay, this number 6. Okay, this one is geometric sequence G7 and G11. G7 and G11. Okay, so G7 and G11. Let me just okay, since we have already looking at the question. That's where it becomes wacky. Okay, so let me just continue. I think it's good enough now. G7 is equal to what's that? 6. G7 is equal to 6. G11 is equal to 3 over something. It's quite, remember that. 3 over 8 or something. Let's see. 3 over 8, yeah. Alright. So what is the question? Maybe we find the common ratio. Okay. So what did it say? Are the 7th and 11th terms of a GP, a geometric sequence, respectively. Find the two possible values of R, the common ratio of this sequence, where R is an element of real numbers. Okay. So it looks to me that we're going to come up with a quadratic equation. This one that they're saying that we should find the two possible values, either a quadratic equation or square one of them. All right, so let's do this. Okay, so seventh term, according to a geometric sequence, right?
Yes.
Seventh term is given by A times R raised to power 6, right?
Yes. It is.
Yeah. So we can now safely conclude that 6, which is the seventh term, is equal to A R raised to power 6. Okay, that is for seventh term. And then 11th term, let's solve this equation 1. And then for the 11th term, 3 over 8 is going to be said that it is equal to AR raised to power 10. AR raised to power 10. Okay. All right. So, yeah, okay with this thus far, right?
Yes, sir.
Uh, okay. So, just initially I said something about simultaneous equation, but um, yes, I think we can see that this is actually a true case of simultaneous equation where two equations are true at the same time. So, what are the things that are going to play out? Now, typically, whenever you have arithmetic systems, because there's plus and minus involved in the mix, it's usually minus elimination method by minusing. But when you have geometric sequences, the elimination method is by division, division style of elimination. So we're going to take out A by saying either equation 2 divided by equation 1, 1 divided by equation 2. Any one would work. Maybe let's do 2 minus 2 divided by, sorry, not minus, equation 2 divided by equation 1. So let's see. Now remember that order. Okay. Equation 2 divided by equation 1 is going to give us, so we're going to start with equation 2. So, 3 over 8 divided by 2. That's for the left hand side. For the right hand side, is going to be AR raised to power 10 over A. I'm sure you can see why I chose to say 2 divided by equation 2 divided by equation 1. Because now it doesn't mean that you can't do it the other way. It's just for simplicity, or should I just say straightforwardness. It's thing coming out much easier. So, of course, nobody will need to tell you that A will cancel itself out. That is the elimination I was talking about. A is out, leaving you with what you really need to find, which is R. And according to, now let's go to the next line. According to laws of indices, we're going to apply laws of indices now. But on the left-hand side, when you're dividing by fractions, right, they told us that the number on the right-hand side, the division can become multiplication, and the number on the right-hand side of the division sign can be flipped or should be flipped. So that's what's going to happen on the left-hand side. On the right-hand side, we will apply laws of indices, which says that when you have a number of the same base, and one is dividing the other, that you can simply say the power of the one on top minus the power of the one beneath. That's the denominator. You remember that law, right?
Yes, sir.
Okay. So this is what we have now. I think it's looking good so far. So let's push it to the answer. We'll keep pushing it till we get to the answer. So this is going to leave us with, of course, things can't cancel out again, as they seem like they'll cancel out. So I left with 3 over 8 times 6 is, oh, okay, things can still cancel out. 3 can go in itself 1. 3 can go in 6, 2. So that will leave us with 1 over 16. So let me erase that 3 that I've already written down there. Okay. going to be 1 over 16. Okay, so I'm sure you can already see what's going to play out here. 1 over 16 equals r raised to power 4. And we're now going to take the fourth root of both sides. Okay, and when I take the fourth root of 16, the fourth root of 16, let me close 16 again. I don't want to take it off. The fourth root of 16 is 2. Uh, fourth root, fourth root of 16 is 2. And the fourth root of r raised to power 4 is r. So that means r is equal to 1 over 2. Okay, so now I know you're wondering what are the two possible values of r. Now, anytime you are taking even a root of a number and that root is an even root, what do I mean by an even root? Whether it's a square root, fourth root, sixth root, eighth root, 10th root, and so on and so forth, the answer will always have plus or minus. Okay, so it's very, very okay for us to say that our answer to this question is actually plus or minus half. These are the two possible values of r. So you know that there are some questions where we will tell ourselves that we are throwing away the negative values because they are not possible. This is not that type of question, and I will explain to you why. Because this is the common ratio. The common ratio is free to be negative or what? Positive. It's very, very free. The only one that is not free to be negative or positive, that can only be positive, is what? N. N is the one that tells you the position, and I mean, it makes sense. Position
Yeah.
of something, you cannot be telling us negative fourth, negative fifth. It's either first, second, third, fourth, fifth, and so on. Okay. So I just thought I should say that in case a question might arise in your mind while we are keeping the negative values for r. All right. So did you get my explanation?
Yes, sir.
All right. So if you want to do a screenshot, let me zoom out so that you can do the screenshot well. Or should I? Let me just scroll up a bit. Let's see. Can you take everything?
Yes, sir.
Okay, nice.
I've done it.
All right. Excellent. Let's go up to continue. Okay. So that line I just drew now doesn't look nice. I don't have to draw straight lines. I never have time to do that. Straight down, 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 down. Okay, so here we go to the next one. So this one that we solved here was actually 5A. So let's go back to the question. Here we have question 5. Question 5 says in the question in this question part, P and Q are elements of what that Q there, I think it's incident, uh set of incidents. Abi? Okay, I'm not too sure now. Or rational numbers. Okay, I think it's set of incidents. Yeah. The following three terms are in arithmetic sequence. P, Q, and what exactly is that? 1 over 4. Interesting. It now says write Q in terms of P. So this question is, well, I'll not say it's tricky, but you just have to be careful. When they say write something in terms of another thing, it simply means the thing they told you to write will be on the left-hand side of the equality sign, and then the in terms of, the one that comes after in terms of, will be on the right-hand side. Okay, so now we have that straightened out. Let's begin. So it's still the same principle as that first one. Arithmetic sequence is, principle is what? Constant difference, common difference. It's steady, doesn't change. So let's um let's take note of the things that we have. P, Q, and 1 over 4. Okay, so it's P, Q, and 1 over 4. Okay, so the question is that these guys are an AP. Okay, so let's keep that one side to remind ourselves, because uh, someone's mind can quickly dash to think that this is a GP, you know, but we have to just follow what the question told us. All right. So remember what they said. Write Q in terms of P. So Q should be, you should be aiming for Q on the right hand side. Okay. So here we go. First things first. Q, and this one Q looks like a man that was Q. I think that's actually what a Q is. Just needed it to be. Okay. So Q minus P equals, should be equal to what? 1 over 4. Remember the principle. 1 over 4 minus what? Q. Okay. So did you get, are you good with this up to this point? We've not really done much, but I just want to make you following.
Jason.
Alright. So Q minus P equals 1 over 4 minus Q. What do you think we should do so that um we'll have the Q's on one side and we'll have the P on its own? What should we do?
Mm, I was thinking, would you say Q equals to
Look at it
we have to
carefully. Oh. You have Q on the left hand side and you have Q on the right hand side. What should we do so that we'll get those two together?
bring it over?
Okay. So we'll take this one over to the left hand side, right?
Yes.
Okay, that's good. And then this guy will come to this side so that it will be the way that I described it at the beginning. You know, one in terms of the other one. So that's going to leave us with what? Q plus Q, isn't it?
Yes, sir.
And then um 1 over 4 plus P. And I think we're very, very close to the answer. 1 over 4 plus P. And then we are going to say Now, oh, sorry. I was thinking that was P. I was already going to write 2P. It's 2Q, not 2P. Okay. So, what are we going to do to both sides now? We have this.
Q, 1/4 plus P.
Mm-hmm. What do we do to both sides so that it's only Q, not 2Q that's on the left hand side?
P.
Yeah. Okay, so can you see what we have now?
Yes, sir.
Would you agree with me that we are still one step away from the answer?
Mm.
Because of that 2 that's in front of the Q, because of that 2. So we need to do something to take care of that 2. What should we do?
And divide.
Exactly. So we divide both sides by 2 so that Q will be equal to, um, let's I don't know how you want to write it, but this time I'll write my own. Dividing by 2 is as good as multiplying by half. So, yep, you want to write your own. You can still simplify it further. People who love to go all the way, they will go all the way. So, either you leave it like that or you go ahead and give an expression that does not have brackets in it, which will be 1/8
8.
plus T/2, right?
Yeah.
Okay, so I think that we're good with this, right?
Yes, sir.
Somebody may still say, want to do the LCM. Well, whatever happens, at least you have gotten an expression that has Q on the the left hand side, and P on the right. Okay, so take note again. We're doing it because they told us to write Q in terms of P. Okay, so that's the implication. And I said that this thing simply means that Q will be the subject of the formula or of the equation, and P will be, dealing with numbers on the right hand side. Okay, so we want to do a screenshot, right?
I've screenshotted.
You've already screenshotted it. I did
Yes,
not
sir.
show the whole thing. Really?
Yeah, for the
I didn't
Q.
know
Yes.
that. Oh, okay, okay, nice. All right. I thought that you hadn't done the screenshot. Okay, so let's go to the next question. What does the next question say? I think it's still following that guy. After is the same question, 1 and 2. This is the second part. So it says the following. Oh, they're different. The following three terms are in geometric sequence. Write Q in terms of P. It's the same thing, but different, differently placed. So this time 1/4 is the second term. 1/4 is the second term. So this is Roman numeral 1. And this is Roman numeral 2. Roman numeral uno. Okay, so Roman numeral 2, the question is P 1/4 and Q. P, comma, 1/4, comma, and Q. Okay, and it is GP. DT, a geometric progression or geometric sequence. All right. So, but just like AP that has common difference that is the same, GP has common ratio that is the same. So that means that 1 over 4 divided by, put the division sign there, will come to handle all the, change all the division signs to multiplication later. That means that 1 over 4 divided by P is equal to Q. Please, oh, this one, in fact, it's not as if this one is more important, but the order is very, very important. It has to be the next term divided by the previous term. So that's why we needed to get it right from the beginning. Or we need to get it right from the beginning rather. So 1 Q divided by 1 over 4. So here we go. Turn all the division signs to multiplication so that we can play fair. And you have that 1 over 4 will be multiplying 1 over 2. Don't worry about the real question yet. As it's evolving, you will see it coming out. Our this thing is still the same. Q should be on the left hand side, and there should be an expression on the right. Don't worry about the fact that Q seems to be on the right hand side, so we can play around with, yeah, okay. Because multiplication I wanted to write that out now turns to something else. Okay, here we go. You see that? So now from here, in fact, from here you can change the side, and make things look as you want it. So we know that Q times 4 is the same thing as what? 4Q,
Yes.
all right?
Yes, sir.
And what happens to this guy this one that was on the left? Let's move it to the right. Now take note, this one is not based on any principle of, what do you call that thing? Moving things around. You can see it's not addition, subtraction kind of scenario. This is purely multiplication thing. Okay. So I just switched the side. Nothing happened. No additional signs in terms of subtract from both sides happened. Okay. So
Okay.
what do you think we can do so that we have only Q on the left hand side? Do you
We
remember
have
we had a
Q.
scenario? Yes. We should have only Q standing on its own on the left hand side. What should we do to both sides?
Do we cross multiplier or just
No,
multiply for
just
Q?
no, let's divide. See, look at that. Do you remember look at what we had back here? Do you remember when we had 2Q in
Yeah.
the previous one? And we divided both sides by 2, right? Because we wanted Q to stand alone. That's the
Okay.
same thing we'll do. We'll divide both sides by 4. So that it's
For
now going to be, yes, we'll now be left with Q equals 1 over 4 times 1 over 4, which is as good as 1 over 16. Okay.
okay.
So let me just, so that somebody's not wondering, how did it become 1 over 16? You know, um, inquiring minds want to know. Okay. So that's going to leave us with Q equals 1 over 16 Q. I think this one was even really cool, like straightforward kind of thing. 1 over 16 Q. Okay, so I think we can do your screenshot.
Wait.
Are you done with it?
My screen is loading. Okay.
Okay.
I'm screenshotted.
All right. See, so let's go and see if there's more over there. Uh, okay. It says what? Using your results from part one and part two. Interesting. Find the values of P. Okay. Not a big deal because now we have two different equations for Q. And so we can safely conclude that this guy is equal to this guy. You got that right?
Yes, sir.
Because both of them are Q. So it's very straightforward to conclude. 1 over 8, let me take note of it. 1 over 8 plus P over 2. So 1 over 8 plus P over 2, okay, equals 1 over 16.
E. Oh,
1 over 16 P.
okay.
Okay. Okay. So, of course, what we did not want to do that other for that other one, we have to do it now. And that is to do LCM things on the left hand side. So if we do LCM things on the left hand side, our LCM is 8. 8 in 8 is 1. 1 times 1 is 1 plus um 2 in 8 is 4. 4 times 3 is 4p. Okay. So I think that okay, let's keep working with it. It's like every math question is like an adventure. You are just going with it and looking for opportunities as you go along the way. That's how I feel sometimes whenever I'm solving math. Okay, so this 8, right? To take care of it, we can. Okay, now let's look at this carefully. Um, you have an equation,
How did you get 1
and
plus 4p?
you know how we do LCM now.
Okay.
LCM, the
Okay.
LCM of 8 is 8. So I just said 8 into 8, 1. 1 times 1, 1. Plus 2 into 8, 4. 4 times 3, 4, 2.
Okay. Okay.
Yeah. Okay. All right. So when you have stuff like this, fraction on the left, fraction on the right, it's better to take the LCM, to multiply both sides by the LCM of um of 12 then. So if we do that, we're going to have we're going to multiply both sides. Let me just use shortcut notation so that we don't spend the whole day on this question. Multiply both sides by 16p because 16p looks like the LCM of 16p and 8. So if we take care of both itself. Okay, so there we go. Multiply both sides by 16p. So we're going to have 16p and then uh, I'm going to have 1 plus 4p. Okay, so you see why I multiplied by 16p because it was safely a good LCM to help us take care of that fraction 8 because 8 will go in itself one time and 8 will go in 16 two times. Okay, now on the right hand side, of course, you can tell what's going to happen. I have that 1 over 16p multiplying by itself will take itself out. 20, the whole of 16p will cancel itself. So this takes place, that's one time, and what do we have here? What do we have left? On the left-hand side, we have, you can see the 2p playing out there.
Yes, sir.
Uh, 2p into bracket 1
1
plus
plus
4p.
P.
Yes. And then, of course, you can see that on the right-hand side, we only have 1 left, so equals 1. I think it looks simpler, right? So we now have, you can let the p go into the bracket. You have 2p. Looks like we're going to come up with a quadratic equation, 8p squared, okay, equals 1.
1.
So, yeah, so there we go. So let's keep pushing it to solve the quadratic equation that just showed up. And we're going to use that method that I introduced you to if it's simple enough, or we may just do almighty formula if it lends itself nicely to it. Let me just push with my sheet as far as I can go. Okay, and yeah, so let's make it a full quadratic equation. So I'm going to rearrange it now so that when I'm substituting it will be easy for me to pick out which is which. HP squared plus 2p. I'm just rearranging things. I'm not moving anything on the left. Then the only one that is going to move is the one that will become minus 1 equals to what? 0, which is our requirement for it to be a full quadratic equation that we can now say, there we go. We can take things out. So this is going to be my A. This is my A. Or, okay, you know what? It's not fair for me to just go and use almighty formula. Okay, so let's ask ourselves that question. Now, remember that method I taught you. I said that if the coefficient of the one that has the square is 1, excuse me, then you don't need to do what we're about to do now first. But since the coefficient of p squared is 8, the first thing we're going to do is to do what? We're going to multiply this guy by minus 1. So the question first, so the question we're going to be asking ourselves is, what are two numbers whose product, let me put times there, whose product is minus 8p squared, oops, I'm doing come up now, minus 8p squared, okay, and their sum is plus 2p. Remember to always take the sign. Their product is minus 8p squared, and their sum is plus 2. So have you thought of two numbers that will meet that criteria? Two numbers, they have to be the same. They must be able to meet that criteria. Think about things that when you multiply them, you'll get 8. Of course, you can start with 8 times 1, 8. 2 times 4, 8. Is there any other thing that can?
2 and 4.
2 and 4, excellent. 2 and 4. So let's see how it plays. 2 and 4. Now, 2 and 4, one of them has to have a minus. Which one should have the minus? Because that's how we will get minus 8p squared. Which one should have the minus, 4 or 2?
Mm,
Because now, do you know how you will know which one should have the minus? Try this in
between two
your
and
head.
two, yeah.
Minus 4 plus 2 and 4 plus minus 2. Add two of them. Which one will give you 2?
Um, that would be plus 4 minus 2.
Thank you very much. Plus 4 minus 2. You are good. All right. So let's see how it's going to come out now. So in our quadratic equation, we are free to write our quadratic equation like this: 8p squared plus 4p, because that's the number that met the criteria, minus what? 2p. So you see what we just did? We just replaced that guy in the middle so that we can have 410 that can help us to nicely factorize, and they ask the usual zero question, the one that if two things, if something times something equals to zero, and that means one of that something is equal to zero, or the other one is equal to zero. So now, can you see what we have? Let's factorize. You can group. This is called factorization by grouping. So we'll group these two together: 8p squared and 4p. What's common there? I'm sure you can see that 4p is common, isn't it?
Yes, sir.
So let's pick 4p out. Now, if we factorize 4p from 8p squared, what will be left? Factorization is just like a playful division in your mind. So
Oh,
factorize 4p. Yes, that will be 2, right?
yes, sir. 2
2p,
p
2p, yes, correct. 2p plus what?
plus
1,
1.
isn't it?
Yes.
Yes, 1. Okay. Let's close the bracket. This is my bracket. Again, I wanted to draw the normal bracket, but I don't know how my hand went and did this. Okay. Anyway, let's continue. It still looks okay. On the other grouping, you can see something, because the next bracket must look exactly like the first one we just got. And the only way that will happen is if we factorize minus 1, isn't it? You agree with
Yes.
me, right?
Yes, sir.
So that's going to leave us with 2p
Minus 1.
plus 1.
Oh,
No, it's going to be
oh.
plus.
Okay, okay.
Plus
Because of the
just
minus 1.
imagine it. Thank you very much. Because of the minus sign. All right. So this is equal to 0. So we'll just, of course, we take one of the brackets, and now take this and the minus 1 as one bracket. So that's going to be 4p minus 1. The ones outside the bracket, 4p minus 1. Okay. And what?
2p plus 1.
2p. Yeah, that's it. What we have here. All this is equal to what? 0. So the principle of when you multiply two things and they are equal to 0 says that any of them can be 0. So um let's start with the guy on the 4p. So we can now say therefore
P equals.
4p minus 1. Oh, sorry. Okay, you already want to go ahead and find p, right?
Yes.
Okay.
Because I
Lightning
was
fast
thinking we should
mind is
just say P equals to 1 over 4 and then P equals to minus 1 over 2.
okay. Yes, yes, yes. That's what it's going to become eventually. Yeah. But if they want to see your working, I guess we'll have to just take it all the way to the end. And therefore, yeah, we have that P will be equal to 1 over 4. Okay. And of course, is equal to, because of that one, the one will cross over, become minus one. It will become minus one over two. Okay, so there you go. I think they didn't ask us to find K, they just asked us to value for K.
Yes.
Is it possible to do a screenshot like this? Or I should zoom out
Yeah,
what
we shorted it.
what you have?
Yes.
Okay,
I've been screenshotting.
nice, nice. Alright, that's good. Okay, so let us move on to the next question. The next question says the general term for another sequence is UN equals n. Is that factorial? That's factorial. N
Mm.
times n minus 2 factorial. Yes, yes.
Is
For
you
all,
know, yeah.
okay, for all n greater than or equals to 2, and n is being elements of natural numbers. Okay, it says that we should show that u n plus 1 equals n minus 1 times u n plus n minus 1 factorial. Hmm. Okay, this show that questions. You have to you have to really show them. Okay, so let's what can I see this? That show question. Let me see. I'm thinking whether let me see. Can this thing go down? If I need more space, is it possible? Okay. I think I it's enough. Can go down now. Okay. Alright, so let me just I'm thinking of doing that question here. Okay. Just so factorial, factorial. Um, UN equals what class again? N times n minus 2 n times n minus 2 minus 2 factorial. Okay. Now, factorial is a product of, for any number, right? It's a product of that number times that number minus 1 times, you just keep on minusing 1 until you get to 1, isn't it?
Yes, ma'am.
Okay. So if we understand that, if that is what it is, then, um, okay, let's see if we can do this. Um, let's interpret this thing further. That UN will be equal to n into bracket n minus 2 And if you subtract 1 from n minus 2, you are going to have n minus 3, right?
Yes. So
Okay. And then we'll just say dot, 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 1. Okay. So maybe I should do it too. Let me see something. So that, it doesn't look like I'm saying something like n minus 3 and dot, 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 and 1. Okay. So that is u n. Then now, hmm, un plus 1. Let's see. Un plus 1 will be equal to n. If we follow the trend of what un is, it means it will be n plus 1. Put that one in some bracket times, now we have to be careful, times n plus 1 minus 2 factorial. Okay. You understand what I just did? I'm just interpreting this based on this. Okay.
okay.
Everywhere I just put n plus 1 because it's un plus 1. You understand?
Yes, sir.
Okay. So let's now the same thing that we did for that un. Let's see if we can do it for un minus 1. Sorry, un plus 1, not un minus 1. So un plus 1 will push it further to the um um n plus 1, n plus 1, okay. And now, let me see, n plus 1 minus 2 is the same thing as n minus 1, and n minus 1 factorial will be um, n minus 1 times n minus 2, because minus 1 minus 1 will be minus 2, isn't it?
Yes.
And then if you want, you can even put just for identity, what am I saying? To show that they're identical, I'll just go ahead and do the next one, n minus 3, and then dot, dot, dot. So I need to push that further a bit, times dot, 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 times, um, times 1. Okay, so I will now fit into this guy's. Okay. All right. So you know what I'm trying to do, right? I'm trying to make it to see where that un plays into un plus 1 because it has to just show up somewhere. Now, I want you to take a look at the second line for un and the second line for un plus 1. Can you see any similarity? Can you see any similarity?
Uh,
Can you see can you
it
see
makes
where you yes, take a look at it carefully. Can you see where you have n minus 2 and you have n minus 3?
Did you add? Mm,
Said it. Okay, let me show you what I'm seeing. Look at this carefully. This bracket, this bracket, all the way to 1 is showing up here, all the way to 1. Okay, so can you see that? I just want you to be able to see so that when we want to do what we want to do now, it will, you'll be able to see how things play out. Now, I'm even looking at something else that is trying to uh I'm trying to see here. I'm having n plus 1 times n minus 1. Um, that in itself looks like something that could give me difference of 2 squared. But okay, let me maybe I should just let me just keep it first. N minus 1 factorial. Okay. Okay. So can you see the similarities of what I'm saying?
oh yeah, yeah.
Yes.
Oh, is
Mm,
it for? Okay, now I understand.
okay. Mm.
Mm.
Okay. So let me see. I'm just n then n plus 1 into mm, this factorial. Okay. So um okay. So see what I want to do. Um all this from here downward is n minus 1 factorial, right?
Okay.
Do you agree with that?
Yes.
Okay. So let's still keep working on this guy. N minus 1 factorial. Take n minus 1 factorial and multiply what you have there, n plus 1, because n plus 1 is multiplying all that. So what you will have is n times n minus 1 factorial minus, let me put that big square around it. Minus, you take this one, n minus 1 factorial, and multiply the 1. Let's say minus, it should be plus, not minus. Plus 1, n minus 1 factorial again. Okay, so do you understand? Did you understand what I just did back there?
Yes, sir.
Okay. All right. So, let me see if it's looking like what we want to arrive at. Okay. So far, it's looking like it. Um, um, maybe not fully looking like it, but at least I already have one part. The second part is already shown. The n minus 1 factorial. Let's look at that. The one on the, what do you call it? This one. Let's look at how we can work on this one now. Okay. So now let's look at where is the un. Un is n times n minus 2 times n minus 3 times dot, 1. Okay.
Okay.
Okay. So um hmm, um okay, yeah. All right, now, yeah. So like I said, let's work on this one that I just put that uh, shape, that thing under. So if you look at it very well, right, that is going to give me n times n minus 1 times n minus 2 times dot 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 times 1, isn't it?
Yes, sir.
All right. So let's just be putting the other one so that we don't think that we have lost it somewhere. Let me just put it like this. Plus n minus 1 plus 2. Okay. All right. So now I want you to look very well at this. Um, I, so this is what I want to do. I want to see where I can bring in that un. Remember un from this the second line for un. That's this place. This place, the second line for un, where I'm putting that arrow there. Says that un starts with n times n minus 2 times n minus 3 1. So if that's the case, I can, multiplication is what they call that thing. Multiplication is commutative. That means you can change position of things. For instance, now, 2 times 3 times 4 is the same thing as 3 times 2 times 4. Do you agree with that?
Yes, sir.
Okay. So I'm sure you can see where I'm going now. It means that I can switch positions of this n and this n minus 1 so that it will become something like this. N minus 1 with his bracket times n. Let me, okay, so now because of I've changed positions, I need to put that times in between. Times n minus 2 times dot. Of course, if I wanted to continue it, I can just keep on doing times n minus 3. If I have the luxury of space, of course. If I do, I can push it a bit. But I don't really have that luxury of space. So I'll just put times dot 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 times 1. Okay. And then do my plus n minus 1 factorial. So, okay, so I don't know if you can see what is playing out now. With that rearrangement, I can confidently say that from here like this, all the way to where you have 1 is un. Okay, do you see that? Look at it very well. From the top here, un starts with n times n minus 2 times n minus 3 times dot 1. Can you see that?
Okay, yes, sir.
Okay. So I think our proof has emerged. N minus 1 times un sounds like United Nations, plus n minus 1 factorial. Finally, our proof has showed up, and that is all thanks to n plus 1. Okay, so did you understand it? I know this one was a bit challenging because it's all letter mixed with numbers, yeah, or more of letters. But you understood it, right?
Yeah, I understand. But like, well, I'll just go over it again.
Okay. Okay. Have you taken the screenshot?
Yes, sir.
Okay. All right. If you go over it and you still have questions, I don't mind explaining it again. Maybe excuse me, when we meet next, I don't mind explaining it again. I'll just take it from the scratch. Okay. So, this one looks like something we've done today, but not so much something like that. It says if this is an arithmetic sequence, find the end term in terms of n and p, where n is an element of natural numbers. Okay, so clearly, what can you say about the common difference from this one? Just looking at it, that question 4b, what can you say about the common difference? Can you
Mm,
see the first term is the second term is p plus 7. So what can you conclude about the common difference?
so I was thinking P. It's just adding
Yes,
7 to the uh like adding 7 to it.
yes, it's 7 to each term, isn't it? It's
Yes, sir.
7 that's been added to it. So I think it's safe for us to conclude that 7 is the common difference, isn't it?
Yes, sir.
Okay. So if that's the case, then we can say that our what do you call that thing? First term. Our first term Q, is P rather, not Q. A is our first term, and A is equal to P. Okay. Common difference B is equal to 7. Okay. Now, you are wondering why did we take this approach? Because of what the question wants us to find out. The question wants us to find out the nth term. So that means that's the term that will generate all the other terms. Okay. And find it out in terms of n and p. So, of course, they've already told us that n is set of natural numbers. So we should be careful. We should not have anything that is negative. Okay. So this is for question 4B1, Roman numeral 1. Okay. Uh, okay. So let me just put 4B somewhere. Okay. 4B. All right. Okay. So, all right. So just for record purposes, so that when you're going through it, you will know which one is for which question. Okay. So let's move on. So Tn, obviously, you know that it's an arithmetic sequence. So that means that Tn is equal to A. Let's do the general term first, and we'll now come and throw in things as they show, as they should. This might A look like Q. Let me make it look like a way A. A plus n minus 1 plus n minus 1 B. Isn't it?
Yes, sir.
Okay. So we know that our A is what? P, according to the question,
E.
plus, and then we'll put our n minus 1 and we'll put our 7 where we have P. Okay. So, you know what we'll do, right? The 7 will go in and take possession of n. It will become 7n minus 7. Yep. And if all this is anything to go by, the like terms here are 7 and 2. So if they want us to, well, if, I don't know if it is safe to leave it like this, but if we remember that P technically is a number, right, then we can just rewrite everything as 7 and then you have your plus P minus 7. Just to arrange it so that the ones that are like terms are more closer to each other. Yeah. So that is it. Because the question said what? In terms of what? N and P. And we have done that successfully. The nth term, where n is an element of natural number. It now says find the smallest value of P. So this is an extension of the one we just did now. Find the smallest value of P for which 2021. I wanted to say 2021. Okay. For which 2021 is a term in the sequence, the smallest value. So that means it's most likely I'm going to be coming up with two values. All right. So that's our job, to find the smallest value of P for which 2021 is a term in the sequence. So what we're going to do is to say 2021. We'll start off with that. 2021 equals
7
7n, yeah,
plus P minus 7.
yeah, plus P minus 7. So now, hmm, let's do something here. Let me see, is there anything we can, okay, okay. Okay, let me go back to this one that we did. Something should jump out from this. Okay, so we've already seen that D is equal to 7. First term A is equal to P. So, hmm, okay, let's see. Um, okay, so 2021 is the only term that they gave us for this sequence. Nothing else is given. I'm not told any other thing other than that part. Okay, let me see. Is there any other deduction we can make? P plus 21 continuous equation. Something should be able to clear out. Let me see. Okay, we're having two unknowns. I'm not comfortable with that. We should have two equations. So that should give us,
I was thinking we should just
yes, I'm listening.
like just bring over 7.
Bring over 7. But how about the n?
Mm.
So, so now that we don't know what the n is,
According to what they said wait, let me see. Did you see what I said?
no, I didn't know what to say. What did you say?
I sent something to
Um, on the
email.
in my
Maybe-
mail.
Yeah, maybe scroll down a bit. Or
Uh,
Not that part.
Okay, okay, okay. It hasn't showed here that it came in. Okay, there's some more information, right, for that
Yeah.
question.
No, it's just that to the marking scheme, they said so to the okay. Should I share my screen?
Okay, yes, 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 yes. Let me stop sharing. it. Yes, go ahead.
I'm trying to switch over. Okay.
Okay, go ahead. Okay. Oh, 2020. So 2028 minus T is the nearest multiple of 7 that is less than 2028. And that's the 2008. Oh, let me see. Okay, the nearest multiple. Okay, so it's because of that 7n that they're saying the nearest multiple. Uh, okay, so they're now equating back to 2028. Okay, sorry, 2023, which will now give us was 5. Okay, hmm. Alright. Okay, I think I'm trying to make sense of their reasoning. 7n because and this is because they didn't give us what the n is, which was why I was saying that yeah, we we needed another equation to be able to get the value of two unknowns. Okay, okay, but let me see. Let me check with you. Do you understand their reasoning here? Do you understand what they said? Here?
Is it yeah?
The reason that they are working here. Do you understand?
I only understand this part, but I don't get this part. Like, I
Okay,
don't. I was thinking maybe they are trying to say that if you multiply seven, I don't really understand. So
okay. So because this is the approach that they have to take. Why? Because they didn't give us any value for n, right? And they're asking us to find the smallest value of p. So the smallest value of p that will make that equation to be true, the 2028 minus p to be true, is such that it has to be an exact multiple of 7, okay? And that is closest to 2028. The nearest that is closest to 2028. And so that closest one to 2028 is 2023. So if you confirm, you'll see that 2023 is actually a multiple of 7. And you
yeah,
won't find the next multiple of 7 will be more than 2028. You
okay,
get it to be more than, you don't want something that is more than 2028. So that's why we had to go for 2023.
okay.
Okay. So that's the reason why that's how they came about that 2023. If not, there are several multiples of 7 before we get to 2028, but we cannot take any of them because they are either too far. Yeah, they are either too far or too small. So the closest is 2023. That's why they equated it with, you can see 2023 took the place of 7N. You can see that, right? Took the place of 7N. So, yeah.
Okay, sir.
All right. So that's how they came about what they did. Okay. So I think oh man, my battery is already giving me time. Oh, I will have more questions. When is your test? Tuesday, Abi?
This Monday last period.
Oh, that's the day after tomorrow.
Yes, sir.
Would you like us to
Sir?
um, would you where would you which of them is the I'm just looking at the question.
I was thinking that I should go through over everything and then the one I don't understand, I'll send it on WhatsApp and then.
Okay, okay, okay. So do you want to look at the others on your own?
Sir?
You want to look at the others on your own, then send only the ones that you can't that you couldn't understand on WhatsApp.
Yes. Yes, sir.
Okay. So the question now is, when are we going to have time to look at it again? Um, how's your Sunday like? I don't know. I never think myself. How's my own Sunday going to be like? Um, after church, what time did I go to? 3 to 4. What Okay, so Sunday evening you're free, right?
Evening, I don't know because I have an appointment to do my hair.
Okay.
But I will
Um,
see. I'll let you know.
can you do that? Okay, you can do it earlier. If you can do it earlier, then I'll try and set a schedule for us to do 4 o'clock your time. Yeah,
Okay.
4 o'clock your time to say, okay, yeah, we can do maybe an hour or two from there, depending on how many questions you come up with. Okay, okay, so yeah, so let's just look at that period, 4 o'clock your time.
Okay,
Then,
I will see if I'm
uh,
available that time.
all right. So you let me know on time so that we can maybe, excuse me, reschedule if
Okay.
we have to.
Okay, sir.
All right. Yeah. Okay. So
Okay.
enjoy the rest of the evening.